Okay, I think I'm up and running. Glenn Kirshner here, because justice matters. Oh, no, that's not me. I'm a math teacher. That's right. All right, so we'll get started with two discussions here. One, how do you solve equations? What's the best approach? Obviously, there's many ways. There's inverse operations, there's factoring, there's graphical approaches, and one other in there that a calculator, but by and large, well, let me start with the story first, and then I'll get into what I want to get at. When I first started teaching, which is ancient history, I didn't have much of a math background. I don't know, went through the motions in high school, took a calculus class or two in college, had no idea what I was doing. But I started at the Algebra 1 level, fortunately. And I had an advisee who was having a very animated discussion with his teacher. She was making him show every step. All right, the classic approach of what you do to one side of the equation is do to the other, and I'm saying we should abandon that. I'm going to state my position right off the bat, and I'll try to explain why as we go along. Okay, I don't like this, and I don't let my students do it. All right, so then the next step is 2x equals what, 22. And then she was making him say 2x divided by 2 equals 22 divided by 2, which is x equals 11. Okay? And he was arguing that, why do I have to do that? Why do I have to do that? I know that 2x has to equal 22. So why can't I just say 2x equals 22? And I know 2 times something equals 22 is 11. Why can't I just do that? And quite frankly, I was on his side. Now, I didn't say anything because it was a colleague, and you got to stand together. Some things that are more important than just solving a simple equation. All right, solidarity, workers' rights. No, anyway, why do I want to see this in my classroom? All right, well, let's start with the basics. Let's start with 5 plus 2 is 7. You can't get any easier than that. All right, and what does 5 equal? 5 equals 7 minus 2. Okay, well, let's take a moment and think about that a little more deeply, because generally you wouldn't, but let's. Addition of 2 becomes what? Subtraction of 2 on the other side. Right? So if you know that, then we're talking inverse operations. Of course, it's important to know the order of operations. Hard to easy, so solving easy to hard for about 90% of the equations. All right, I'm going to get to an equation here in a little while, but we'll just make one up on the fly. 2 log base 3 of 4x minus 5 plus 6. We'll solve that in a little while, and we'll make that equal to 12. And I would expect my students to be able to solve that in 20 seconds or less. Again, I'm going to ask 70 questions in 70 minutes. You got to know your stuff, or you're not going to finish the exam. All right, so let's construct another one. 5 times 3 equals 15. Okay, well, what does 3 equal? It sure looks like it's 15 divided by 5. Looks like division on the right is multiplication on the left, or multiplication on the left is division on the right. Again, pushing inverse operations. So let's look at how would you solve for x if you had 2 times 3, let's see, 5, let's put a 5 in here. 5 cubed. So 125, so 250 plus 7 equals 257. All right, so I just made a canned problem. What do I expect my students to be able to do if trying to find that answer? Addition becomes what? Subtraction. Multiplication becomes what? Addition. Cubing becomes what? Cube rooting. That's all I want to see, right? I wouldn't even expect that. I would expect my students just to know the cube root of 125 is 5. Right? That's all I want to see. And we knew that was what the answer was, or what I started with. I can correct that a whole lot easier than if somebody starts to do minus 7, minus, oh God. Let's promote thinking. Let's promote computation. Weaker computational skills come to my way every year. I don't know why. I don't want to put not enough repetition at an earlier level. We got to start this in kindergarten, first grade, promoting thinking. So here's that problem that I put up here. And in a minute, we're going to talk about transforming this in a graphical standpoint. And I expect my students to be able to graph that in 30 seconds or less accurately. All right, so we'll do that in a moment. So what do we got here? Subtraction of 6, division by 2, log base 3. Oh, I should have picked another number here. Just a moment. So if I'm changing this, let's make this 4x minus 3. Let's make this 5, just because some people maybe, log base 5 of x inverse is 5 to the x, and that takes a while to learn. All right, and so I don't want to confuse anybody who's just beginning to consider this for the first time. All right, so we have a log base 5, that's the inverse. All right, so let's go back and do this now. Let's get a canned problem. So if this is 25, 2 times, I don't want it because that's a 2 and a 2. Let's make it 125. So, but that's a 6 and a 6. Jeez. That's all right. Let's make it 125. And a 6 and a 6, I believe, is still 12, right? So 3 and 6. Yeah, okay. So canned problem. Subtract 6, 6. Divide by 2, 3. Log base 5, 5 to the. Subtracting 3. So now we got 125 and 3, 128. And then dividing by 4 is 32. Get done. All right, and I've got students who can do that just as quickly and easily now. All right, move on to the next problem. All right, but let's check it. 4 times 32, 128. 128 minus 3, 125. What's the exponent that you put on top of 5 to get a 125? A 3. And then you can see 6 and 6 is 12. Check. All right, now I wanted to talk about transformations. I just forgot what I wrote, so I will write some new function. So let's say that f of x is, and I got another story. So let's say we got 2 log base 3 of 4x minus 5 plus 6. All right, so we got that function. And the parent function is log base 3 to the x. All right, so let's see. Been teaching about 20 years, and some students, 3 young ladies came. I allowed to say ladies, I don't think so. 3 young, gentle women came to my duty on a weeknight in tears. They were pre-calculus honor students, and they were crying. They couldn't figure out how to shift this graph. So we'll call this f of x. And they wanted to know, let's see where I can write this, what the graph of, let's say, 2f of 3x minus 5 over 6 plus 7 looks like. What will that graph look like? They've been working on it for 3 days, quite a bit. And let me just use this other board for a moment. And what's taught? What's taught for transformations? You take an x squared graph and not even values over here. And what does, and that's called f of x, right? And then therefore, what does say 2 times f of x minus 3 squared plus 4 look like? Something, no, sorry, that is the square code. So what might something like that look like? Well, you generally talk about some kind of process here, right? And we'll get back to this kind of stuff in a minute. But what's the first thing students hear? The parent function. Get ready for this now. The parent function shifts 5 units to the right. Boom. Well, imagine being a student who's just starting to study algebra and you hear about numbers shifting. I don't know about you, but I don't think a dance class should be interjected into the discussion. You're working with numbers. You want to work with numbers numerically. Right? So that you get a feel for the calculation. A minute ago, I introduced, the inverse of log base 5 of x is 5 of the x. Well, you got to do some of those. 5 to the negative 2, 5 to the negative. Get a working knowledge. So I think that's very confusing, talking about shifting 5 units. I think this measures change in the squaring process from 5. All right, so what's the squaring process? All right, 0 gets you 0, 1 gets you 1, 2 gets you 4, and of course it's the same thing with the negative numbers, right? So you got to do some negative work. But that's the squaring process. Whereas, let's forget this for the moment, if you're looking at x minus 5 squared, then you get a 0 when you put a 5 in. You get a 1 when you put a 6 in. You get a a 4 when you put a 7 in, right? So, yeah, there's a shift there in perspective, but you gotta crunch the numbers. Then you can have discussions about, well, there's no area when you put a 5 in, right? And then link it to some geometry. Okay, so back to the conversation. How do you do a problem like this? Well, it only took us 5 minutes and the tears were gone and the kids were out the door, right? Because, and then I'll graph this quickly and I'll graph that quickly because I expect students to be able to graph that. I've had students graph that in 10 seconds or less. Takes a month or two of practice, but to get there. And it doesn't take long to, put one on a worksheet and just keep doing them so that you may remember it for the next class. All right, so how to graph this? Well, let's put some numbers in here. I should have put some numbers in. Let's say that a -6 gets you 0. Let's say that a -3 gets you, I don't know, 7. And let's say 0, 0 here, going through the origin. I don't have to finish this out here. Let's put this at -5, not drawing the scale, -11, et cetera, et cetera. All right. So how do we sketch this? Well, we have to have some knowledge. What knowledge do I have? I don't think that's going to be on the board here. So I'll pick something else. Let's pick the origin, 0, 0. I know that f of 0 equals 0. Okay, well, how hard is it to make 3x minus 5 over 6 equals 0? Not at all, 5/3. Okay, so over here at 5/3, I know that location. Okay, I think this one's going to be off the board, but I also know that f of -3 produces 7. So maybe I'll make that 8. I'll make that 8. I don't like any of the same numbers showing up when we first tackle an initial topic. So what do you got? 6 times -18, -18 plus 5, -13 divided by 3. I now know that f of -13 divided by 3, when I plug that number in, I'm going to get f of -3, which is 7. And 7 times 2 is 14. 14 plus 8 is 22. I knew I'd be off the board, but I'm up there, and now we've got this section of the graph graphed. That's all I had. They were very bright students, and that's all I had to do was those 2 problems, and they finished the list. And they had their graph, and they weren't crying anymore. All right. Instead of talking about how do you describe this to a student that doesn't even know what log base 3 of x looks like, because they haven't had enough practice with that. I don't think it's possible. That's why students aren't able to graph logs. All right, so how do you graph that log quickly and easily? Well, you establish some logs you know. All right, and the 2 that I push, well, there's 3 logs I push. I look, log base 3 is 0, log base 3 of 1, and log base 3 of 3. That's all you need to know to get this graph quickly and easily. And then maybe, talking about shifting 5/4 might have some meaning. Shifting your perspective to different numbers. So why is this important? Well, it's undefined, right? So this is undefined. So you can have a discussion about positive arguments and why you have them. And if it's the inverse of exponentials, then you can bring up the words growth and decay. What's the inverse of growth and decay? Well, you better have something there or it's not growing or decaying, which is why, at least it's some kind of statement as to why that has to be positive. So you have that discussion. You also want to have these numbers. Why these numbers? Because you've got multiplication, and isn't it nice to multiply by 1 and multiply by 0? Right? So this one gets you multiplication by 0, this one gets you multiplication by 1. Because what are the easiest numbers to multiply by? 0 and 1, then you might as well create them. So let me just go ahead and do this right now. So look at that. What makes a 0? X is 5/4. What makes a 1? 6 divided by 4, so 3/2. 3/2. I know that this is a positive, a bigger number than 1 and a positive multiplier, so I know this mental shape. Right, so that's going to locate one number. And if I created that, which is 0, 0 times 2 is 0 is 6, so it becomes templative. In other words, when you use this number in the argument, you always get the constant. And when you use this number, you always get the coefficient plus the constant. So I know that's going to get me 8. Right? And if I make this a 3, so 8 divided by 4 is 2. Let's just show that real quick. 4 times 2 is 8, 8 minus 5 is 3. What do you get when you put on top, what do you put on top of the 3? You get a 3, you have to have that discussion, you're looking for the exponent on top of 3, that gets us 3 to the 1, obviously it's a 1, times 2 is 2, plus 6 is 8. You had that. Now, I guarantee that if you're pushing transformations, you're not gonna get there that quickly, no way. All right, so I'm just putting it out there that I think some things need to change. And I think, again, I don't know if sequential teaching gives enough time to actually understand the inverse operations of this. Yeah, I think the inverse operations are there, but enough working knowledge so that it's brought into the next class, working with it long enough. I don't think so. You got to work with things on a daily basis. I know I had a lot of students at the algebra 2 level, shocked me one year when a whole bunch of them couldn't write the equation of y. I didn't spend time writing it. I just assumed it was in somebody's pocket. We did cover it, but early in the term and until later in the term. So I threw the book out the window and said, we're going to do the equation of line, every day. And what took the kids 2-3 minutes, actually, they had to learn it because they actually hadn't had it learned from algebra 1. So it took them 3 or 4 days to kind of get the mechanics and learning it. And then by doing it every day, well, now they, take 10 seconds and I haven't had anybody get it wrong since 1993. Occasional, 7 minus 5 is 1 kind of error. Okay, but the mechanics of it, the number of right answers on lots of tests suggest to me that there may be occasional careless error now and then, but nobody gets it wrong anymore. And so why not adopt that approach for every other problem? Get through it and then put it on a worksheet and make kids do it. And pretty soon they're doing this and with ease. At least my algebra 2 students are now, and it's the end of the semester and it's taking that kind of time. But boy, the graphing pages now are just being done quickly and easily. And I think that's movement in the right direction. All right, so the comments, tests cannot be turned on because YouTube doesn't allow them for videos for 18 and under, I guess, or under 18. And, I'm doing a lot of videos for the students. So I wish I could get some comments on something, a discussion like this. I'm happy to have my mind changed, open-minded, but I need some proof to me that, we want to start talking about the graph shifting 3 units to the right, vertically up and stretching, keep that for a yoga class. Right now we want to crunch numbers. And so I put the case out there for some changes and we'd love to hear opinions, but not going to be able to. All right, let's hope that this video uploads and I'll post it. Have a nice day, everybody.